In this video, I wanted to do an introduction to storage in Azure. Now, storage for the most part, is storage. There's not really that much difference between storing something locally versus storing something on the cloud. However, there can also be great differences on how that information is stored. What kind of redundancies and controls I have for something locally versus having something in the cloud. We'll start off this discussion by talking about the types of storage that's out there on Azure, or more specifically, the levels of redundancy and protection for things out in Azure. Here we have a slide that talks about the different types of replications that are available for Azure. The very first one that we see here is locally redundant storage, sometimes referred to as LRS. Locally redundant storage essentially takes your data that you store in Azure and keeps 3 copies of it. It multiplies your storage by 3. Now, this may seem a little bit overkill, but basically that means that if I upload my resume.doc into Azure, then that means that not only is resume.doc up there once, it's up there 3 times. And the idea being that if the hard drive that it is stored on in Azure dies for some reason, I still have 2 viable copies of it running in Azure. So if my one hard disk fails, I still have 2 additional hard disks to recover it from. Compare that to the hard drive on my local computer. If the hard drive on my local computer dies, I pretty much have lost all of my data. If I'm lucky, I have a backup somewhere and I can be able to restore from that. But for the most part, if it dies, it dies. I've lost my resume. Locally redundant storage in Azure means that it is automatically available from a second and a tertiary location. So that means I can have not just one hard drive fail, but 2 hard drive fails simultaneously and still have my storage available to me. The second option for storage in Azure is what's called ZRS, or Zone Redundant Storage. Zone Redundant Storage takes the idea of locally redundant storage and separates it across different zones. What that means? Well, if we look at the Azure regions, there are approximately 54 regions across 140 different countries. Locally redundant storage, for instance, when we're talking about my resume, always got to watch out for my resume. If I store my resume in, say, Canada East, then that means it is stored 3 times in Canada East. That is LRS, locally redundant storage. Zone redundant storage looks at some of these special availability zones, such as these guys that have the stars down there. Availability zones are basically 3 or more buildings in one region. So zone redundant storage still keeps my resume in the same region, such as West US, but in this case, it's in 3 different buildings. Worst case scenario, a meteorite comes falling out of the sky and crashes down on one of those buildings. If I store it over here in Canada East, a meteor hits that one building that everything is stored in and everything goes out. I lose my resume because everything was stored in one building. If I put it in zone redundant storage in West US, my data is now stored across 3 different buildings, all within the West US 2 zone or region. Meteor comes out of nowhere, slams into one of those buildings. One building is entirely gone. It's a horrible thing to happen. I feel sorry for Microsoft, but my resume is still safe because it was stored in other buildings in that same region. So zone redundant storage and locally redundant storage, same kind of idea. However, zone redundant storage is stored across multiple different buildings in that region. The third option, geo-redundant storage, GRS. Basically, when we look at our regions, well, our data is stored. Let's say we store our resume right here in West US. What happens is it makes a read-only copy. Read-only. And it copies it to a second location, such as Canada East. That means if the entire west coast of the United States goes dark for some reason, major power outage, something causes everything on the west coast, major earthquake, major flood, something like that, everything on the west coast is completely unavailable, then that means I could still go to Canada East and restore my resume. My resume is available over there. It's currently in a read-only format. There is actually a switch I could do to change that read-only to a read-write. And let me tell you, if the entire West Coast goes dark for some reason, I want that resume available to me because I'm looking for a job somewhere that's not on the West Coast. Yeah. So, geo-redundant storage as opposed to locally and zone redundant storage. The very last option here is read access geo-redundant storage. So read access probably makes it pretty obvious. Well, it's still GRS, it's still geo-redundant storage, except my second copy that's in another location is I can read it. There we go. I can read it in that remote location as well. So it's not simply a copy that I can't use until my primary is unavailable. It means I can then read both copies of that resume. So some of those importance come in a lot better once we start talking about databases and financial transactions as opposed to a resume. A little bit more detail about how the redundancy works. We talked about LRS, which is this guy right here. LRS, we have our local data, we copy up our resume, we copy up our database, we copy up whatever other information we might need, for instance, into the West Japan region. It then creates 3 copies onto 3 different sets of hard disks so that if any one or even 2 sets of hard disks fail, I still have a third online, fully functional copy that is working. When that first or second set of hard disks fails, what happens is a new set of hard disks is immediately identified and then data is copied from the working environment to it, so that if for some chance that final set of disks fails, we have already copied our data to another redundant configuration. Constantly making sure that our information is as redundant as possible. When we then talk about geo-redundant, either read available or just simply geo-redundant, that data is then copied to East Japan or some other region. And again, 3 copies are stored in that remote location. Awesome. It's practically impossible to lose data in Azure due to failures of the equipment. Now, when we're talking about this, we also then have to deal with some pricing, which can be of question. For instance, if I only have 1 copy, let's say I'm not dealing with, let's say somehow I talk to Microsoft and I say I only want 1 copy, I absolutely do not want the second and third, I'm not going to pay for it, so maybe I'm going to spend $1 for that storage. Well, then that means that if I eventually decide that I need those additional copies locally, then I need suddenly another $1 and another $1. So in theory, I'm spending $3 in total for my locally redundant storage. However much you pay, it's going to depend on where you're at and how much storage you actually need. So let's say I'm actually spending $3 for my LRS storage. Well, as soon as I start deciding that I need more redundant storage, well, suddenly because I have three 3 additional copies in my second location, I am suddenly doubling my storage costs. So instead of $3 over here, I then have $3 over here as well. So that's $6 plus replication costs. So now not only am I paying double my storage, I'm also paying a little bit more for that replication to occur, because that's a WAN of some sort. Somebody has to be able to pay for that internet connection. So there are lots of great resources here, lots of great configuration types that we can choose from. LRS is the most basic and the least expensive. Read access GRS is the most expensive. Different business purposes will have different needs, and therefore will call for different configuration types. All right, within Azure storage, there are different types of storage that are available to us. There is what's called queue storage, and this is a very weird type of storage. Imagine you have a help desk. Probably the simplest way to describe it. Imagine you have a help desk. Somebody sends in a ticket. That ticket goes into a queue or a pool of other tickets. Eventually somebody pulls a ticket from the queue and starts working on it. That's the simplest idea to explain a queue. The other way would be able to think of a line. You go to the Department of Licensing and you need to get your license renewed. Therefore, you go to the DOL, you get in line. And then as soon as the line moves forward, you eventually get your license. Yeah, queues in real life kind of suck. From a computer standpoint, they are awesome. Queues can actually do a whole lot more than that, but that's probably the simplest way to explain it. Second option is table storage. Tables, think of this as similar to Excel. Similar to storing data in Microsoft Excel, there is a whole lot more information in here. For instance, if you're familiar with the idea of JSON data or JavaScript object notation, table storage can actually store JSON data in a non-relational database type. Read about it. I'm not going to go too far into it. Third option is what's called blob storage, or binary large object. The idea behind blob storage is anything that can be stored in a binary format can be stored in blobs. So that could be files, that could be videos, that could be music, that could be hard disks, such as these guys over here. It can be pretty much anything you want that can be stored under blob storage. And then lastly, the fourth type is file storage. And that is literally file storage. If you've worked on a Windows server in the past and you have created file shares, that's literally what we're talking about here. Your file storage shares files amongst computers. All right, well, so that's the very basics of the Azure storage. Let's actually look at the storage environment and see what we can do. So right here, I have the Azure portal logged in. Let's go ahead and just create some storage. So I'm going to create resource. Let's see, storage. And I want to create a storage account. Here, I'm going to go ahead and select the resource group that's available to me, since I'm using this through the Microsoft Learn sandboxes. Let's go ahead and give it a name. Only lowercase and numbers. Let's see, it still doesn't like my dash. How about an underscore? Nope, doesn't like that either. So we'll call it ECG storage 001. ECG, those are my initials. And then storage, the 001 means I can go all the way up to 999 here. Location, West US 2. I've changed these in the past and have had issues with the Learn labs working in other regions, so I don't change them anymore. We then have the performance. What performance tier do we want? There is probably a whole lot of information behind this configuration right here. Basically, if we choose standard, we're talking hard disk drives. We're talking spinning magnetic media. It's very high capacity, but it is also fairly slow. For premium, we're talking about SSDs. It is very fast, somewhat more expensive, and very fast, and not quite as large capacity. Looking at the instructions that are coming along with this lab, it tells me to choose standard. So I'm gonna stay with standard. I'm not really doing anything that's going to require SSD at this point, so I'm going to stay with standard. The account type, storage V2. There is a storage V1 and blob storage. There's absolutely no reason for me to go with anything but V2. It's the default. It's going to fit for almost every single configuration you need. And then replication, what type of replication do we want? Do we want LRS, ZRS, GRS, or RAGRS? Again, I'm not doing anything that requires excessive redundancy and excessive availability of my data, so I'm going to go with locally redundant storage. By the way, if you're concerned about having your data available, you can actually look the SLA for Azure storage. And there are service level agreements defined for this. Let's see, the very first LRS. There we go. So LRS and LRS has, oh yeah, it's the same for both. 99.9% availability. So that's 3 nines of availability for LRS. Once you get to GRS and RAGRS, you then start talking about 4 nines. Those are actually lower than I expected. I expected them to be significantly higher. Yeah, it just talks about, but still fairly high level availability. The last question here is, what access tier do I want? Is the data I'm going to be using accessed a lot or a little? If it's accessed a lot, I want to choose hot. Basically think of, how close or where you put things in your closet. Where do you put your clothes in your closet? The clothes that you wear the most frequently are probably at the front of your closet. Those shirts, those pants, those shoes, you wear those a lot, therefore they're at the front of your closet so you can get quick access to them. If I access things only a little, I'm going to put those in the back of my closet. Now, here comes the question of cost. If I'm accessing something a lot, it then costs me, in theory, a lot of money. In theory. This is kind of where the breakdown of the closet idea goes away. If I'm accessing something a whole lot, it's going to cost me a whole lot of money. Or if I'm going to access things very rarely, maybe I could put them in a box and put them in the back corner, then it costs me very little. So, hot storage versus cold storage. How frequently am I going to access this environment? Next, we then go to network. How am I going to access this data? Am I going to access it from the internet, which is a public endpoint? All networks or select networks? Or am I going to access it from my private environment? My private environment, particularly on Azure. In this case, I'm going to say public endpoint because there's lots of flexibility that it allows us to do. If I had a very isolated environment, such as if this was a backend storage hosting data for an internal environment, I might choose private. Probably should choose private if I chose that. Advanced. Should I require secure transfers? That's the answer for that question is probably going to be yes, regardless of the technology you're using nowadays. This basically means, should I use HTTPS when I'm accessing the data? And the answer, absolutely yes. Data protection, Blobs, soft delete. Do I want to immediately delete the data, or do I want it to kind of be tagged as deleted and then eventually go away? Soft delete allows you to save and recover your blob data if snapshots are deleted. It allows you to just kind of say, oops, I didn't mean to do that. It costs a little bit more money. You can see here it retains it for 7 or more days. Oof. I could retain it for up to a year after I deleted it. Or I could say no, because, hey, this is a test lab. I really don't ever expect I'm going to recover this data. And then data lake. Data lake, the idea behind a data lake is I have a lot of data. I have some Word documents. I have some Excel spreadsheets. If I could spell Excel. I have some databases. I have all kinds of data that are all important to me, and I want to be able to search all of them at the same time. Instead of creating one big, huge database to put all this into, what I do is I put them all in the same place. And at that little circle there makes it kind of look like a lake. Yeah. So I put it all in one place, and then I'm able to search it using specific tools that allows me to search Word and Excel files and databases all at the same time. Again, we don't need that here. Tags, just like every other tag environment, you can go ahead and name these however you want. For instance, department. If I'm creating this storage account for a specific department, then I can go ahead and tag it that way. Or billing code. Oh, well, let me take spaces. So I type in a billing code or whatever else I want to put in there, simply for reporting and organization management. When we're done, we go ahead and click create, and our storage account will be quickly created here. It doesn't take very long because it is actually pretty short deployment that is required. All right, and now that our deployment is complete, we can go ahead and go to that resource. And right down here, as we scroll down from the overview, we can start seeing our services, and you'll start to see that a lot of those services are exactly the services that we saw that were available for the environment. We have our queues, which I said are sometimes confusing, but fairly helpful. We have our tables, again, sometimes confusing, but think of these like our Excel databases or Excel spreadsheets. We then have file shares, which is our SMB file shares. And then containers, which oftentimes is for our blob data. All of these are available once we have our storage account. Well, let's go ahead and take a look at this. Probably the easiest one to think of is the file shares. Again, if you've worked on a Windows NT or a Windows server, you've created file shares. It is just this simple. To create a file share, we call it whatever we want. Let's call this, let's go really, really smart here and call it file share 001. freaking out because it's capitalized. We can specify quotas if we want. I don't really want to. Clicked OK. It defaults to a quota of 5 terabytes in size. Oh my goodness. Click on it and we can start browsing. We can upload files if we really want to. Let's see what kind of files I've got to upload. There we go. Additionally, what we could do is we can actually click this connect button. I believe this is the one. Yes. And it gives us a PowerShell script or a bash or command line script to run. If we open this up and we open PowerShell, I'm just going to paste this in. What it does, assuming my firewall will allow me to do it, is it actually maps a network drive from my local computer up into Azure. At which point I can then access this Azure file share as if it is a local drive on my computer. I believe my firewall is blocking me, so I won't necessarily wait for that. So you can do that both Windows, Linux, as well as Mac machines. That they all work well. These commands actually have the path or the server name. Actually, look at the Windows machine here. The server name, ECG storage 001.file.core.windows.net. It then also has the username and an encrypted password in order to mount the drive. So it has everything we need, at which point, like I said, it acts as if it's a locally mounted hard drive on my computer, or locally mounted share on my computer. I can delete files, I can change quotas, add additional directories under here, so temporary, or whatever I want. It's literally a file share. Yeah. Oh, what, too far back? Storage count. There we go. Tables. This is where things get a little confusing sometimes because, well, what exactly is a table? Well, so we can come in here, we can create a table, test table. Say okay. And in here we can, if I remember exactly how to work these tables, which apparently I don't. Oh, I know what it is. I need to go back. Storage Explorer. Here we go. Storage Explorer allows me access to the tables. I knew it was somewhere in here. And here you can add in interesting data such as, oh, I'm actually going to draw a blank on this one. I'm not actually sure how to do this. What we do, here's what we do. We open up Google and we say Azure table examples. And there are lots and lots of people out there. Oh, that's talking about writing in code. There are lots and lots of examples out there about people creating tables. That's an Azure Cosmos DB table. But they talk about what it is, how to make it work. There we go. And so on. I'll let you guys enjoy that one. Queues. I've never actually found a good queue example, but yeah, how do we create a queue? Test queue. And then inside test queue, you can put information in there and then you can take information out. Huzzah! Again, Google queues under Azure. They have some special use cases. It's not something that you're going to use on a daily basis unless you specifically need those queues. And then lastly, the containers. This is where some of the blob storage would be. So container 001. I can also make this a public type container. It's blob, anonymous, read access. There we go, for containers and blobs. What I can do by making this a public access of a container, I can actually create a website and host it through here. Otherwise, I come in here and I can start uploading files or any type of content I might have for my environment. It looks very simple to similar to a file share. However, blobs have some unique capabilities such as extremely large sizes. I believe the limit is somewhere in the terabyte range. Normal Windows file shares cannot handle terabyte sized files, as well as we can what's called chunking. Imagine I'm a video editor. I'm editing some videos and I need to change one little frame that's halfway through the movie. Because I'm chunking it, what I can do is I can actually open up just that chunk or just that section of the video, edit it, and then save the whole thing again. Keeps me from having to download everything and then uploading it again. This is exceptionally useful for hard drives, specifically virtual hard disks used in my Azure virtual machines. Aha, there we go. That's why we really use it. Not just hard drives, but also for databases. So I can actually store an Azure, a Microsoft SQL database out here or some other database and have very quick access to this storage as a blob type that because of the chunking, I'm only loading and saving just those chunks that are actually necessary. So there you have it. That was a very brief introduction to storage under Azure. Again, we can replicate these things all over the place. We can configure encryption. We can use what's called a shared access signature to where we can share things with a special key that can then easily be revoked. Websites exporting. Azure Search, CDNs, we can replicate our data for public consumption throughout the world. All kinds of great things with Azure storage.